So I am going to do two of the problems from pages 295 and 296. I've already done two of the problems from 295. Actually, I've already done three of the problems from 295, 296. Actually, I've already posted those videos that showed three of the problems from 295, 296. Now, I'm going to do two more of the problems from 295, 296. That tells me, let's see, 1, 2, 3, I'll do 4 and 5. That tells me that by the end of this class, 5 of the problems from 295, 296 will be posted. And maybe, just maybe, I'll do another 2 problems from 295, 296 and post that after my last class today, sometime before I leave tonight. It's a possibility. Who possibly knows? Like anyone could even know that. So now let me forecast what's going to happen. So Scarlett, let me tell you what's going to happen. There are students that are in this room right now that are going to miss some of the problems that I'm doing and recording. Either because they've turned it in and they're like, I don't want to get it out. I'm too lazy. Or they're going to not watch the videos on the TubeView and they're going to get them wrong. Even though before the end of this class, posted on the TubeView, you will have 5 of the questions from your assignment that will already be posted, which would be silly to get them wrong. I know, right? I know, right? Okay, so it'd be silly to miss those problems. I'm just saying. But it'll happen because of the effort that some of you don't put forth. Okay? So let's look at, let's say, problem 4, which the instructions are for you to find all of the factors of 45. Now, what I've seen on some of the papers is some of you are not putting all of the factors of 45. Some of you are putting one of the factors of 45. Some of you are putting 2 of the factors of 45. Some of you are just wiping your boogers on the paper, hoping that it will be a good grade. Don't rub boogers on the paper. Okay, so the divisibility rules are very helpful when we're listing the factors. Very helpful. So, I should have told you to glue those in your journal. The divisibility rules.
You did.
I did! So you have access to them. What a brilliant teacher I am telling you to do that. All right. So, we always start with 1 times 45. Or 1 times whatever your number is at the top. And if we go through the divisibility rules, the divisibility rule for 2 says a number is divisible by 2 if it, in the ones place, has a 0, a 2, Matthew, are with me, a 4, a 6, or an 8 in the ones place. That means that number is divisible by 2. Does 45 divisible by 2? No, because it doesn't have a 0, a 2, a 4, a 6, or an 8 in the ones place. All right. our rule for 3, and since you don't have it out, I'm just kind of telling you, our rule for 3 is if the sum of the digits of your number add up to a multiple of 3, your number is divisible by 3. Now the word sum tells us we're doing what?
Addition.
Adding. So what is the sum of the digits 4 and 5? 9. Good. Because 4 plus 5 is 9. We're just adding the digits together. Is 9 a multiple of 3?
Yes.
Yes, 3, 6, 9. That means this number is divisible by 3. Anybody know how many times 3 goes into 45? Anton? 15. Thank you, Anton. Okay, we don't have a rule for 4, but I'm going to tell you it's not divisible by 4. The rule for 4 is if you can divide it by 2 and then divide it by 2 again, which we can't even divide it by 2 once. Okay, we have a rule for 5. If the number in the ones place is a 5 or a 0, then that number is divisible by 5. So is that number divisible by 5?
Yes.
Yes, because it has a 5 in the ones place. Now let's just pretend like I don't know how many times 5 goes into 45. When they get to this point, you can always look at your multiplication table. For those of you that are not too hard-headed to actually use your resources that your brilliant teacher has made you put in your journal. Now, Katie, 5 times what equals 45? 9. Excellent, Katie. There's no need to yell it out because you were the only one saying it. So please don't yell out the answers again, even if I call on you. Okay? So my factors of 45 would be 1, 3, 5, 9, 15, and 45. Now some of you may not have listed them in order from least to greatest. You may have made 1 and 45, 3 and 15, 5 and 9, and that's fine. I'm cool with that. However, if you don't include all of them, that problem will be marked incorrect. So if you only include 4 of them, bam, that problem's wrong. You will not get it correct. Well, when the last ones as close together as you can get. Now the rule for 6 is it has to be divisible by both 2 and 3. Is this divisible by both 2 and 3?
No.
No, just 3. I can see on my chart. Okay? There's no rule for 7, but I can look at my multiplication chart. It doesn't work for 7. On my multiplication chart, 8 doesn't work for that. And now I've done everything between 5 and 9, so that tells me that I'm done.
So it's 45 and that's the closest. 45?
Yes. All right, so let me add one thing that's not on your homework assignment, but is on the group task you're going to do today. You're going to make factor arrays today. My thought is you've probably done factor arrays when you were first learning multiplication. You probably did factor arrays. Some of you may have not, but let's look at factor arrays because you're going to have to do that today. When we find all the factor pairs, a factor array where you're going to have a chance to use graph paper. A factor array for 45, and I'm not going to draw all the squares in it, would be 1 and 45. That would be a factor array for 45. But there are more. 3 and 15. So 3 by 15. And there'd be one more. 5 and 9. And what you'll notice when you're doing these factor arrays, that the number of squares inside each of these factor arrays is going to equal the number you're doing. So if you did these and you thought it was 1 and 43, and you counted, oh wait, there needs to be 45 squares inside my factor array. Okay, so you'll be doing this. And when you're asked to make factor arrays for the number, you have to include all the different factor arrays. So if your group has the number 45, and you don't include all 3 of the different factor arrays in it, just throw it anywhere.
But is it going to get lost?
Probably. But, you know,
I'll be back.
that's just the way it works in my desk.
Yes, I know, but that means you're, what, brilliant? Isn't that right?
Yes, I think that's what that means, is messy desks mean brilliant.
Oh, brilliant.
All right, so let's look at one more that may be on the assignment that you have due Friday. Let's look, and you know I always give you time to do these. Let's look at 36. Again, listing all the factors for 36. Listing all the factors for 36. We always start with 1 times 36. Is 36 have 2 as a factor, Taylor? Yes, because it ends in an even number. So it'd be 2 times 18. Does 36 have 3 as a factor, Reed Jones? What's the sum of the digits? What's 3 plus 6? 9. Does 3 go into 9? Is 9 a multiple of 3? 3, 6, 9. Yes. So 3 times 12 is 36. Okay. Now we're getting to the point where we can look at our multiplication chart. Is 4 a factor of 36?
Yes.
Yes. 4 times what? 9.
No.
Is 5 a factor of 36?
No.
No. Because it doesn't end in a 5 or 0. Is 6 a factor of 36? Okay. So it would be 6 times 6. So on the paper, if it asked you to list all the factors of 36, you'd list it 1, 2, 3, 4, 6, 9, 12, 18, and 36. Nothing times 7 equals 36. Okay? And if you were asked to make factor arrays of the number 36, you would have 1, 2, 3, 4, 5 different factor arrays because you have 5 different factor pairs. So how many ever factor pairs you have, that's how many arrays you're going to have. Now make sure you understand the arrays. You did that on purpose.
Sorry.
Make sure you understand the arrays because you're going to have to do the arrays. Are there questions? Boom, shakalaka. Peace out. Bless y'all. Love y'all.